Hey everyone, this is Mr. Anziano recording a solutions video for the free response portion of the test review for our upcoming Unit 1 test. Mrs. Keener just posted the answers and the PDF to the multiple choice part, so hopefully you will have some time to look through that and make sure that you understand why the answers that are posted are correct for each problem. All right, so here goes the free response part. I'm looking first at free response number 1. Where we are given the graph of a piecewise defined function called h right over here. And we have a few tasks, right? The first one is asking us if h of x is greater than or equal to 0, we have to explain in words what that means graphically, right? So really, we've seen this a few times now. We know that when h of x is greater than or equal to 0, that tells me that the graph is either on or above, right? So h of x being greater than or equal to 0 tells me, or implies, that the graph of h of x is on or above the x-axis. All right, and this is going to occur on the interval from -5, we're on the x-axis, right? We can follow that upside down quadratic all the way over here to -2, where although we would continue going down into negative land, we know that right at -2 we are on the x-axis. So that both of those values should be included in that first interval. So closed interval from -5 to -2. All right, but we're also on or above the x-axis when x is on the interval from open at -1 all the way out to positive infinity, right? So we are on the closed interval from -5 to -2, union, or the open interval from -1 to positive infinity. Okay. Oh, there go the lights. So that's my first answer for number 1, letter A, excuse me. Next, we need to find the values of x for which h of x is equal to 3. Right, so our reasoning there, we know that h of x is equal to 3 when the graph has an output or a y value at 3, right? So I'm going to explain that in writing. H of x equals 3 when the graph of h of x has a y value of 3. Right? And this occurs in a number of places. Right? When do we see that the graph has a y value or an output of 3? Well, we find 3 on the y-axis. We see that it happens there, there, and again over here. Right? So when x is equal to -5 is our first output of 3. When x equals -3, we have an output of 3. And when x equals 3, we have an output of 3. All right, so not intervals for letter B, but specific x values. Okay, now on letter C, we now have to graph a new function. Okay, so we're going to graph f, which is defined by negative absolute value x plus 2 plus 4. Okay, so what does that look like? Well, we know that we have a vertex at -2, right? Our horizontal shift is always going to be essentially opposite whatever the sign inside the function expression is. So we are moving 2 units to the left and 4 units up to give me a vertex of -2, 4. All right, we know it's concave down because we have a negative in front of the absolute value quantity. And also we kind of know that the slope is going to just be 1 over 1, right? So my absolute value function is going to look a little something like this. Using my handy dandy lanyard, I got some nice straight lines that are going to go from -2, 4 down into the left forever, and down into the right forever. Okay, so there's my new function. Next, we have to state for which values of x the functions are equal to one another. Right? Well, when does f of x equal h of x? We need to explain. Okay. And really, I think we all know the answer is when the graphs intersect. Right? When the graphs intersect, they are equal. So I'm just going to write again in writing, because it's asking us to explain, f of x equals h of x when the graphs intersect. Thus, f of x equals h of x when, let's see when we have those intersection points. Although my graph doesn't necessarily go all the way down to -5 as far as where my line ends, we know that ray is going to go out down into the left forever, right? So we are going to intersect at -5 because we have a closed circle on the quadratic, and that line does pass through -5. So that's my first x value. We see that we also intersect the quadratic at -3. So we have another x value where the two graphs are equal. And finally, we intersect this square root function of the piecewise defined function right here when x is 0. So in 3 locations, the two graphs are equal to one another. Oh, sorry if you could not see that whole thing. We have 3 locations where the two graphs are equal, right? So we have a location at -5, a location at -3, and another intersection location at x equals 0. Okay. This last one is a little bit tricky, and that's kind of usually how these free response questions are going to work. They get progressively more challenging as you go, but if you've done the previous ones correctly, usually the last piece is just the cherry on top. All right, so if p of x is equal to 3 times ax squared minus 2x, then for what value or values of a does p of -1 equal the quantity 2 times h of -5 plus h of 0? So we got to show our work. First of all, guys, we know that in order to find the value that we're looking for, in order to find a value to set p of -1 equal to, we have to work this thing out, right? So I need to know h of -5, and I need to know h of 0. H of -5, okay, I'm going to move this back up here to the graph. H of -5 is when my original function, not the absolute value function, but the original piecewise defined function containing the quadratic and the square root function, the output at -5 is 0. So h of -5 is just 0. Okay. And what is h of 0? We need to know h of 0 as well. H of 0 is the y value when x is 0 on the square root function, and it turns out that h of 0 is just 2. Okay, h of 0 is 2. Thus, this entire quantity, 2 times h of -5 plus h of 0, simply equals 2 times 0 from what we realized the output of h of -5 was equal to, right? 2 times 0 plus h of 0 is just 2. And that's just 0 plus 2, which is 2. Okay? So, really, the question is asking us, when does p of -1 equal 2? Right? We just replaced this entire expression right here with 2, so we need to figure out when p of -1 is going to be equal to 2. Okay, so this may seem like a challenge because you're noticing that p of x has 2 different variables, right? It has an a variable and an x variable. But the nice thing is, guys, we're looking for when p of -1 is equal to 2. And that immediately tells me that x is actually just -1, right? So all I really need to do is find what p of -1 is equal to by plugging each x value, substituting in for each x value the number -1. Okay, so really that's going to be 3 times a times -1 squared minus 2 times -1. And that's just 3a times 1 And then negative 2 times negative 1 is going to give me a plus 2. All right, so that's just 3a plus 2. P of negative 1 is just 3a plus 2. So putting it all together, we now need to find when 3a plus 2 is equal to 2, right? When does 3a plus 2 equal 2? I'm going to set them equal. 3a plus 2 equals 2 is going to be my new, what is that, a two-step equation, right? Subtract 2 from both sides and we get 3a equals 0. Well, if 3a equals 0, then of course a has to equal 0 due to the zero product property, or simply dividing both sides by 3, however you want to look at it. So a has to equal 0. All right, I'm just about out of space at the bottom here. 3a plus 2 equals 2 when a is 0. So we can kind of check it here, right? 3 times 0 plus 2, does that equal 2? Absolutely. All right. But I'm going to check it back in the original equation just to be sure. Okay. So my check should look like, well, 3 times 0 times negative 1 squared minus 2 times negative 1 should be equal to 2. And is that what happens? We get 3 times 0 times negative 1 squared minus 2 times negative 1. Is that equal to, with a question mark, 2? All right, well, 3 times 0 times, well, anything is going to be 0, so that is 0 plus negative 2 times negative 1 is, again, positive 2. Does 0 plus 2 equal 2? Absolutely. All right, so that right there is free response 1. Okay, I'm going to zoom out just a little bit so you've got all of the solutions one last time. All right, and due to the fact that I've got just 3 minutes left to record, I'm going to go ahead and make a different video for free response number 2. So thanks for watching. I'll be right back with you.